Hi, this is Laura Slominski with Edina High School, and today we are starting a new chapter about rational functions. Section 10.1 is called Graphing Simple Rational Functions, and the objective is that I can graph f of x equals 1 over x minus h plus k, and g of x equals a over x. So we start by defining what a rational function is, and it's a function of the form f of x equals p of x divided by q of x, where both p and q are polynomials, and q of x can't be 0. The simplest rational function is f of x equals 1 over x, and today we'll get to know these. So domain, if we're thinking about f of x equals 1 over x, we can think about how we can divide 1 by anything except for 0, because division by 0 is undefined. So in interval notation, and make note that this u means union, the domain of this would be written from negative infinity to 0, but then you'll notice it's a parenthesis because it can't include 0, and then with union of 0 to infinity. So you can see it includes everything except 0, and this is a way that we can write this in interval notation. Now we're going to start talking about end behavior at a vertical asymptote, so you can pause this now if you want, but with your calculator or with your brain, we're going to fill in, and again we're still dealing with 1 over x. So we're going to look at what happens as x gets larger and larger. So if I do 1 divided by 100, so plug 100 in for x, I get 0.01. If I do 1 divided by 1,000, I get 0.001. And if I get 1 divided by 10,000, I get 0.0001. So hopefully you're noticing that the larger x gets, f of x is getting closer and closer to 0. And so we can actually think about that as x goes to infinity, so as it keeps getting bigger, bigger, and bigger, f of x is approaching 0. Okay. Now we can think about x getting smaller and smaller and smaller, or going to negative infinity. So if I go to 1 over negative 100, I get negative 0.01. If I do 1 over negative 1,000, I get negative 0.01, sorry. And 1 divided by negative 10,000 is negative 0.0001. So again, we can see as x is getting smaller and smaller and smaller and smaller, so as x goes to negative infinity, f of x is also approaching 0. Okay, so because the end behavior is a number and not infinity, we say that f of x equals 1 over x has a horizontal asymptote. The equation for a horizontal asymptote is, remember it's always y equals, and it's equals 0, those two numbers we just got. Now we're going to talk about the behavior near x equals 0 in a vertical asymptote. So since we said x equals 0 is not in the domain because we can't divide by 0, we're going to examine the behavior of f of x near x equals 0. So we're going to make x get closer and closer to 0. So in this case, we do 1 divided by 0.01. When we do that, we get 100. When we do 1 divided by 0.001, we get 1,000. And then when we do it divided by the next one, we get 10,000. So as we can see, as x is getting closer and closer to 0, so as x goes to 0, we'll talk about what that plus means in a minute, f of x goes to positive infinity. Okay, so this right here is from the positive side. Which on the graph would be from the right. Okay, so as it approaches 0 from the right, or from the positive side, it goes to infinity. And if we do the same thing over here, we get negative 100, negative 1,000, and negative 10,000. So again, as x gets closer and closer to 0 from the negative side, so this means with that negative in the upper right-hand corner, it says from the negative side, which again on the graph would be from the left in this case, we can see that our numbers are getting bigger and bigger as negatives, so they're going to negative infinity. Okay, so because the function approaches but does not cross the y-axis, we say that x equals 0 is a vertical asymptote. So what we've learned so far is that if I go to graph f of x equals 1 over x, we said that there is going to be a vertical asymptote at x equals 0, and a horizontal asymptote at y equals 0. So this is the first time we've looked at a graph that actually has both a vertical and a horizontal asymptote. Now we're going to use these tables to continue to find some other things, and again we're still working with the equation f of x equals 1 over x. So if I plug in 2 for x, I get 1/2. 1 divided by 1 is 1, and 1 divided by 1/2 is going to be 2. So every time I have a positive input, I end up with a positive output. If I plug in -2, I get 1 over -2, so I get -1/2, -1, and -2. So negative inputs have negative outputs. So now I know they have these two asymptotes, but now if I go and plot these, again, this first one would be the point 2, 1/2. So I go over 2, up 1/2. I go over 1, up 1, and I go over 1/2, up 2. So what we can see is that this left table gives me a piece of a graph. We said it's going to travel along the asymptote through those 3 points and along the horizontal asymptote. So we can see that there's a piece of the graph, but remember, it's not going to cross those asymptotes. So when I go to graph table 2, or the table on the right-hand side with my negatives, I have a point at -2, -1/2, -1, -1, and -1/2, -2. So we can see that again, it's going to travel along the asymptotes through those points along the other asymptote. There's zeros on the end. So you can see that the graph of 1 over x, because it's undefined at 0, actually has those two different chunks for the graph. We flip over to the back side of our note sheet. We're going to just have one final question to that, and we're going to look at that graph that we just looked at, and I can actually scroll and see it. It says, look at your graph. The function takes on all real numbers except 0. So the function's range, if I go from bottom up, it goes from -infinity to 0 again, but remember, it doesn't cross 0. So the union, and then it starts up right again after 0, so 0 to infinity. Okay, so we can see that the domain and range of 1 over x is actually the same. Okay, so now we're going to talk about how we shift. So as we said in our notes at the beginning, ultimately, we want to be able to graph f of x equals 1 over x minus h plus k. And hopefully, when you saw that, or when you see it now, the minus h and the plus k sounds familiar, because it is in fact going to be another example of what follows that rule, where if something is grouped with the x, it's going to shift it left or right, so horizontally, the opposite of what you would think. And if a number is separated from the x, so the k in this case, it's going to affect it vertically, as you would think, so up or down, as you would think. Now, grouped with the x in this case, there won't be parentheses, but it's if it's in the denominator of the fraction with the x. Okay, so when I look at g of x here, I see the x minus 3 in the bottom, so you could put it in parentheses, you don't need it to be, but that is grouped together because it's in the bottom of the fraction together. So I remember anything that's grouped with the x moves it left or right, and since it's x minus 3, I know that it's going to move it right 3. And then finally, this plus 1 that is on the end, it is going to move it up 1. So what I need to do is take those asymptotes. So first I'll take my vertical asymptote, which was at 0. I'm going to move it to the right 3, so it's going to be at 3. A vertical shift doesn't affect the vertical asymptote, but it does affect the horizontal asymptote that was at 0, so that's going to go up 1. And now once I have that, you could actually think about it as starting from a new origin. We said we always have a point over 1 up 1, over 2 up 1/2, over 1/2 up 2. Okay, so it shifts this graph to right here. You could also take each of those points and shift them right 3 up 1 from the original. And then here I have -1, -1, -2, -1/2, and over 1/2 down 2. So we do want to make sure that we get the correct shape, and those 3 points are important for when we get to the next thing. Now when I go to write my domain, remember the vertical asymptote affects the domain. The vertical asymptote is now at x equals 3. So you can see that it now still goes to -infinity, but now it gets to that 3, that line at 3, but it's not included. So we'll see the union with, and then it starts right after 3 and goes to infinity. Okay, so those asymptotes will change our domain and range. The range goes down to negative infinity, and it always will, but now it comes up until it gets to this horizontal asymptote, which is at 1, so that was y equals 1. And then union with it again, it starts right away again, goes from 1 to infinity. So we always have to make sure we jump over that asymptote. And this is the notation in the middle we use for that. I would pause this now and try the next example of graphing on the right, and then restart it to see that you're on the right track. So I see the x plus 1 in the denominator, which means it's going to shift it left 1, the minus 2, which is going to move it down 2. So first I took my vertical asymptote at 0, shifted it to the left 1, took my horizontal asymptote that was at 0 and shifted it down 2. So if I want to, I could now say there's a horizontal asymptote at y equals negative 2, vertical asymptote at x equals negative 1. Once I have that, again, I think about this as kind of my new origin. Go over 1, up 1, over 2, up 1 half, over 1 half, up 2. So in my first quadrant, I have this curve, and then again, I go back 1, down 1, back 2, down 1 half, back 1 half, down 2. So I get those 3 points set so that it's got the right shape, and then I travel along my asymptotes. So that's just our regular shifting that we've reviewed over and over again. Your domain in this case should be negative infinity to negative 1, union with negative 1 to infinity. And range should be negative infinity to negative 2. Negative 2 to infinity. And now, so that was the first objective, is being able to graph these shifts. And then finally they said, well, what about graphing just a over x? So let's take a look at this last example. You'll notice that the thing that's changing now is the number on top. So we're not shifting at all, we're just changing the top number to see what happens. Well, one thing to think about is 2 over x, just so we know, is the same as 2 times 1 over x. And so if I plug negative 2 in, I get a negative 1, negative 1, I get negative 1, oh, sorry, negative 2. Negative 1 half, I get negative 4, positive 1 half, I get 4, 1 I get 2, and 2 I get 1. So since it hasn't shifted at all, I should know that when I graph this new one, it should still have the same vertical asymptote, the same horizontal asymptote. And you can see f of x is already drawn in there, but now we're going to graph g of x. So I have a point at negative 2, negative 1. So instead of that negative 1 half, I have negative 1, negative 1, negative 2, and negative 1 half, negative 4. So as I graph this, it would still go along the asymptotes, but you'll see that it is actually stretching away from those asymptotes. So this middle part is actually going further away from the asymptote. If I graph the positive quadrant, I get the same idea. I go over 1 half, up 4, over 1, up 2, and over 2, up 1. So again, you can see it has the same shape. However, we can see that it is stretching away from the asymptotes. That's if A is greater than 1, since it was a positive 2. And now in part B, or this next part, h of x, we've got 1 over 3x. I just want to note that there's a couple of different ways we can write that. It's the same as 1/3 times 1 over x. We don't usually write it that way, but just so that we understand it's the same. Or we could say then that 1/3 is the same as 0.33 times 1 over x. And the reason that's important is because this table will show us what happens. Well, what if that a value is less than 1? Okay? So when I did 1/3 times 1 over negative 3, I actually get 1 over negative 9, which is negative 0.11. 1 over 3 times 1 over negative 1, I get negative 0.33. So negative 1/3. I got negative 1, positive 1, positive 0.33, and positive 0.11. So again, we haven't shifted at all, so my vertical asymptote stays here, my horizontal stays here. I plot my points, negative 3, negative 0.11, negative 1, sorry about that, negative 1, negative 0.33, and negative 1/3, negative 1. So what we can see when we do this is that it actually gets closer to the asymptote, so it's compressing towards the asymptotes. And we would get the exact same thing off this one. So 3, 1 is 0.33, and 1/3 is 1. Okay, so final notes here are that if absolute value of A is greater than 1, it stretches away from the asymptote, and if absolute value of A is less than 1, it compresses towards the asymptote. Thank you.